Let's go ahead, and here we see what is called as the logical equivalence of two statements. So the two statement patterns S1 and S2 are said to be logically equivalent if they have the same truth values in their respective columns of the truth table. And if the two statements are equivalent, then we denote them as S1 equivalent to S2 as shown here. Okay, so let us solve one example based on this. Prove the following logical equivalences using the truth tables. Okay, so here P implies Q is equivalent to negation P or Q, which in turn is equivalent to negation Q implies negation P. Okay, now if you recollect, the last part is nothing but the contrapositive of the original implication. So here we are going to prove anyways an important result that the contrapositive is equivalent to the original implication. So to prove this, we will need several columns in the joint truth table. So let's start building them one by one. So first we would write, of course, the primary columns P and Q. Okay, then if we look at the second statement pattern, we would need the column of negation P, so we make it. Then we write the negation P or Q. So let us write negation P or Q. Or better, like we have to first prepare the implication also. So let us do that. Let us just make a slight change. We'll first add the column of implication so that it comes in the correct order. Okay, so let's first build the implication column. Okay, then we have negation P, then we have negation P or Q, okay, which gives us the second statement. Alright, then to build the contrapositive, we would need negation Q also. So we have negation Q. And next we do the implication of negation Q and negation P, and we have already prepared the column of negation P. So the last column would be negation Q implies negation P. Alright, so let us complete the truth table using these columns. Now since here also we have only two constituent statements, so we write their respective combinations. Alright, now we have to prepare the implication, that is P implies Q, and from the truth table we know that it is TFTT. Then next we have negation of P. So the column of P is to be negated, so we have FTT. Alright, then we have to do the OR of negation P and Q. So these two columns we have to do the disjunction, that is OR. So in OR we know that at least one is true, then the whole is true. Okay, so here we have true, and only when both are false, like the case here, it will be false. So we have this column as TFTT. Okay, then we have to do negation of Q. So the column of Q is to be negated, which gives us FTFT. And lastly we have to do the implication of negation Q to negation P. Right. So we have F implies F, that gives us true. Then true implies false, that gives us false. Then F implies true, that is still true, and true implies true is also nothing but true. So now therefore look at the three columns marked here. We see that all of them have exactly the same truth values at any particular row. So therefore, no matter what combination of truth values of P and Q we consider, the three statement patterns given are always equivalent to each other. Okay, so that proves the given equivalence.